Okay, so we have a paradox here, birthday paradox. Okay, so let's start from the beginning. Okay, like we have a person A. This person has the birthday. Let's imagine that as year, month, and day format, right? And we have a next person. That's gonna be our person B. And let's think what is the probability that these two people shared the same birthday. Like if this person has the birthday 20 June, what is the probability that this person also shared the birthday 20 June? If we consider the leap year, it's gonna be 360 1 by 366. If we don't consider the leap year, it's gonna be 1 by 365, right? It's not it's a very low probability, or we can say that it is very less likely to happen. Okay, we did the basic. Now let's move on to our paradox. So the paradox is the birthday paradox is an answer to a question that is actually the correct and supposed to be a correct answer, but it doesn't seem correct. That's why it is a paradox. It is a paradox. So that's why it is a paradox. Okay, so let's write down our question. Okay, the question's gonna be like this. So how many people do we need to consider so that it's more likely than not that at least two of them share same birthday? So how many people do we need to keep in a room so that there's more probability of at least two of them sharing same birthday than not? Okay, so here we're asking that mm, how many people do we need to keep so that there's the probability of at least 51% that at least two people share the same birthday, right? Okay, so we might think that the answer is gonna be just a lot of people, but that's the wrong answer. It's not gonna be that many people. It's gonna be just 23 people. The answer is 23 people. Okay, so let's see how. Okay, so uh, there are a total of, we are not gonna consider the leap year here. We're just gonna consider that there are a total of 365 days in a year, or 365 different birthdays, right? Okay, so to make it that at least 51% people share the same birthday. Sorry, at least 51% probability that at least two people share birthday. We're gonna need at least 23 people uh, in a room, right? So how? Okay, so out of 23 people, like 23 gonna be a lot of dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20, 22, 23. Okay, so what we're asking here is, okay, there are a lot of pairs possible. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So you get it, right? There's just too many pairs, which we can calculate through combinatorics. That's going to be 23 take 2, or just 23 c 2. This is a combination problem, which we can calculate as 23 factorial by 23 minus 2 factorial into 2 factorial. Let me calculate that real quick. So there's a total of 253 pairs here. All right, 253 pairs, and from that pair, at least one pair must share a same birthday. That's our goal. Now, from now looking at the number of pairs possible, there seems to the answer 23 might seem somewhat correct. Okay, we can interpret it as another way as well. Uh, Rather than finding uh, that the probability of two people sharing the birthday, let's find the probability of none of them sharing the same birthday. Like we have a person A and then person B, right? Then now what is the probability that A and B doesn't share a birthday? Like A has a birthday, right? And the probability of B not sharing the same birthday with A is considering just 365 days in a year. We're not taking leap year in consideration, so it's gonna be 364 by 365. Now, likewise, we have a total of 23 people, and up to 23 people, right? So now the probability are gonna just multiply with each other. Now of C not sharing the same birthday with B and A is 363 by 365, and the next people not sharing birthday with all these people is 362 by 365, and the next person not sharing the same birthday with all these people is 361 by 365. Now up to 23 people. This is just gonna continue up to 343, I guess. 343 by 365. Now all of these are gonna multiply with each other to find the probability that none of the 23 people share the same birthday with each other. Now just let's see here. This is of course less than 1 because the denominator is larger than numerator, and this is the same for all of these, right? Now if we multiply any two or three or multiple numbers that are less than 1, they are gonna just keep on decreasing and decreasing. Like we have zero point 0.2 into 0.1, this is gonna be 0.02. Okay, so if they multiply these two numbers, it's gonna be just 0.02, which is less than this both the numbers which we are multiplying. Now, if we keep on multiplying these, and the probability is gonna be a very small number, so it is less likely that none of these people are gonna share the same birthday as compared to the probability of at least two of them sharing the same birthday. Now, if we find the probability of this, it's gonna be 0.49. It's gonna be about 0.49 of not of anyone not sharing the same birthday, and in percentage, it's gonna be about approximately 49%. So there's 49% chance that none of them share same birthday. So from here, we can say that there is 51% chance that at least two of them shared the same birthday. So yeah, we proved that it is 23. Now, if we were asked to uh, how many people do we need to consider so that it's confirmed, it's 100% sure that at least two of them share birthday. Now the answer is gonna be, now that's gonna be 366 people. If we use this same logic and find the probability of that none of the people are gonna share the same birthday, we at some point gonna add with multiply something into 0 by 365, and 0 multiplied by anything is 0. So there will be 0 chances that none of the people will share the same birthday. So it is 100% sure that at least two of them will share the same share birthday. Or just look at other way. Here we are considering leap year doesn't exist, right? So 365 people, let and say every 360 all the 365 people doesn't share the same birthday. So every 360 all the days of the year are gonna be covered with 365 people, and now that extra people will gonna have the birthday, gonna share the birthday with at least one of these people. It can be more again, it can be more, but he or she gonna share the birthday at least with one people. And it seems quite similar with the pigeonhole principle, which says that if there are n plus one or more objects passed through n holes, there's gonna be at least one hole from where more than one objects are passed through. Okay, I hope you every one of you understood the paradox. All I did was just yap around, and so I'm hoping it was quite the video was knowledgeable and you did understand. Not that I hope anything, not that I expect anything from my teaching skills though.